I wasn't planning to revisit 3i Atlas today, but late last night, a sequence of images from the Nordic Optical Telescope lit up the professional feeds again. The reason? The comet's trajectory, according to several reduction pipelines, had moved, ever so slightly but measurably. For weeks, astronomers believed the course of 3i Atlas was locked in. Its inbound orbit, hyperbolic and stable, showed the classic signature of an interstellar visitor: high eccentricity, no previous perihelion, and negligible non-gravitational acceleration. Then, a new pattern emerged. Datasets uploaded between October 20 and 22 began showing a right ascension drift of nearly 0.4 arcseconds compared to the official JPL ephemeris. On paper, that sounds trivial until you realize that at 2.3 astronomical units, that offset equates to roughly 700,000 kilometers in projected space. Could a comet really jump that far in a week? Or are we chasing ghosts buried in the data itself? NASA's Jet Propulsion Laboratory quickly flagged the anomaly for review. The Minor Planet Center requested raw fit submissions to verify calibration and reference catalogs. Early checks suggest some of the amateur frames used mismatched Gaia DR2 catalogs, while others employed uncorrected light time adjustments. Yet several professional stations, including the Keck Observatory in Hawaii and the Gran Telescopio Canarias, confirmed the same residuals after internal cross-correlation. That's when the whispers started. 3i Atlas might actually be changing course. To understand the stakes, we need to recall what this object is. 3i Atlas is only the third confirmed interstellar object ever recorded. Its discovery in late 2024 by the Asteroid Terrestrial Impact Last Alert System was a milestone. Spectroscopy from Hubble and ESA's Mars Express showed complex hydrocarbons and metallic nickel far above typical comet ratios. By July 2025, observers noticed something unprecedented: a sunward jet, a narrow plume of material pointing toward, not away from the sun, what specialists call an antitail. For 3 months, it held steady, defying the textbook physics of sublimating comets. Then sometime between September 15 and 16, that jet collapsed, replaced overnight by a standard dust tail streaming away from the sun. No one could yet explain the mechanism behind the reversal. And now, barely a month later, the object's measured position seems to be off by nearly 1 million kilometers. Astrometry on active comets is notoriously fragile. When jets flare, they distort the photocenter, the weighted centroid of brightness used for orbit calculations. Shift that centroid by half an arcsecond, and your predicted path can veer off by astronomical distances. Teams at ESA's ESOC and JPL's Solar System Dynamics Group are currently rerunning orbit fits using adaptive point spread modeling to isolate the nucleus from the asymmetric coma. But here's the uncomfortable part. Even after those corrections, a residual offset remains, small but consistent across independent instruments. If it's real, the implications stretch beyond academic curiosity. A non-gravitational acceleration of even a few millimeters per second squared could suggest unknown outgassing geometry, or, more provocatively, mass redistribution inside the nucleus itself. Could internal fractures, triggered by solar heating, be propelling Atlas off course? Or are we witnessing a more exotic form of momentum exchange, something we've never modeled before? The Parker Solar Probe and ESA's Solar Orbiter are both in favorable positions this month to detect any increase in charged particle flux along the comet's path. If Atlas is venting volatiles toward the sun, plasma signatures should spike. So far, telemetry shows minor fluctuations, but not enough to explain the magnitude of the drift. Meanwhile, a new dataset from the Vera Rubin Observatory's commissioning camera hints at a faint optical halo extending beyond the predicted coma radius, possibly debris from fragmentation. If a portion of the nucleus broke off, the center of mass could indeed shift, producing the illusion of a course change without external forces.
But until those images are verified and released to the public archive, no one can confirm the hypothesis, and that's fueling speculation online faster than scientists can debunk it. Across X, formerly Twitter, posts tagged Atlas shift and course change have exploded. Amateur astronomers are uploading their own overlays of JPL and IAWN data, each claiming proof of a deflection. Most are misscaled or ignore centroid bias, but the trend illustrates how thin the line has become between citizen science and panic. NASA's Planetary Defense Coordination Office released a brief statement earlier today. There is currently no evidence of any hazardous deviation in 3I Atlas's orbit. Minor variations are under active review as part of normal astrometric calibration. A diplomatic way of saying we see something, but we're not sure what it means yet. For now, all eyes are on November 5, when the comet will re-emerge from solar conjunction. That's when ground-based telescopes will regain visibility, and new triangulation data will settle whether this is simply an optical illusion or a genuine shift in trajectory. One thing is certain, the story of 3I Atlas isn't over. It's only beginning to test how well we understand the motion of objects not born under our sun.
Just days after the initial reports of 3I Atlas's shift, researchers began cross-checking every possible cause. Was it an observational error, a thermal jet, or a true trajectory change? Tonight, we look deeper into the numbers and the physics behind the mystery. Every comet responds to sunlight differently. When 3I Atlas swung inward past the frost line, NASA's SOHO and ESA's solar orbiter both recorded jets of volatile material bursting from its surface. These plumes act like miniature thrusters, gently pushing the object off its predicted path. But the strength of these jets doesn't quite explain the data anomaly. According to a 2025 JPL review, the acceleration vector was slightly misaligned, suggesting either asymmetric outgassing or an unknown mass distribution inside the body. Hubble's ultraviolet spectrometer detected fragments of diatomic carbon and trace cyanide gas, the same chemical markers found in 2I Borisov. However, the light curve of 3I Atlas shows irregular dimming patterns inconsistent with simple rotational tumble. The amplitude changes hint at a possible fragmentation or a volatile-rich cavity venting unpredictably. At the European Southern Observatory, independent amateur spectroscopists compared 3I Atlas's albedo to past models and confirmed the object reflects sunlight more efficiently now than during its entry. That could mean it's shedding darker crust material or exposing inner layers never seen before. While NASA attributes the change to surface activity, several private astronomers argue that the motion's consistency suggests an external torque. The Planetary Society modeled potential magnetic interactions but found no measurable effect at such distances. Still, data from the Parker Solar Probe indicated minor magnetic fluctuations along the object's inbound corridor, small, yet curious enough to keep the discussion open. In science, anomalies are gold. They force us to recheck, rethink, and recalibrate. 3I Atlas might not be rewriting physics, but it's reminding us that the sky above still holds more variables than our equations predict. As the headlines spread, 3I Atlas is changing direction, social media erupted with theories. Some claimed it was guided, others insisted it was breaking apart. Between speculation and science, the truth lies in patient observation. On Reddit, X, and YouTube, creators shared simulations suggesting intelligent control or artificial origin. A few compared its velocity pattern to ʻOumuamua in 2017, the first interstellar visitor that displayed a similar non-gravitational acceleration. But NASA's Center for Near-Earth Object Studies, CNES, clarified 3I Atlas's motion is fully consistent with a natural comet under intense solar heating. The direction change is measurable, yes, but predictable under new thermal models. Dr. Lori Glaze, director of NASA's Planetary Science Division, emphasized transparency. We publish all positional data in open repositories. Anyone can verify our calculations. Meanwhile, the ESA Comet Interceptor team cross-referenced ephemerids from multiple observatories, confirming the offset aligns with increased solar pressure near perihelion. In the information era, data moves slower than speculation. The phrase, "NASA is baffled," trends faster than NASA is recalibrating. But every recalibration deepens our precision. 3I Atlas is not an alien craft, but a cosmic reminder that even small forces in deep space can mislead the eye and spark the imagination. We'll next move beyond the controversy to what this moment teaches us about detection, science communication, and the next interstellar traveler we might soon encounter.
In the silence of space, every visitor leaves a trace. 3I Atlas, our third interstellar object, is not just a curiosity, it's a scientific opportunity that arrived uninvited yet perfectly timed. NASA and ESA teams are now improving early warning algorithms based on the Atlas event. The upcoming Vera C. Rubin Observatory, launching soon, will scan the entire southern sky every few nights, capturing transient interstellar visitors before they fade. 3I Atlas has shown how critical rapid detection and collaborative data sharing are in this new era of cosmic discovery. Studying 3I Atlas's composition refines our models of how planetary systems form around distant stars. The ratios of carbon and silicates suggest chemical kinship with objects in our own Oort cloud, hinting that the processes that build worlds might be universal. Beyond equations and light curves, there's wonder. This small frozen traveler has crossed the gulf between suns, and for a brief moment shared its reflection with ours. Its faint shifting tail carries both data and poetry, a reminder that even in precision science, mystery remains our most honest companion. 3I Atlas will soon vanish into the outer dark once more, but in its wake, it leaves new eyes, sharper instruments, and renewed curiosity. Proof that the universe still knows how to surprise us.